Um, okay, so today we're going to be going over counting numbers of paths. So at first you might think like, this is really easy, and it is, but like what I'm talking about is oftentimes in math counts or AMC, you're going to be given a grid like this and asked to find the number of paths from A to B. So there are two methods to counting the number of paths, but we're only going to be going over one. There's one that uses like combinations and permutations and stuff, but today we're going to be going over like the easy method.
Right? A fun method.
Yeah. Okay. So this is the example problem. An ant is traveling on the lines shown. If it starts at A and up, how many paths can the ant take from A to B? So I have a feeling a lot of you might not know how to solve this, right? Because I didn't explain anything. So in order to start for any grid, you have to start by labeling the bottommost and leftmost vertices with the 1. Basically, both the sides that the starting point touches. So if the starting point was B, we'd number the rightmost and the topmost. But since the starting point is A, we're gonna number the leftmost and bottommost sides with the 1 for each of the vertices. So then you take the next vertex, which has the vertex below it and the vertex to the left of it labeled. So currently the only vertex we have that fits that criteria is this one. I don't know if you all can see my mouse. Can you?
Yes, we can sort of see it.
Okay. Okay. The only vertex that fits this criteria, okay, let me just like draw, is this one right here. So we will add the number to the bottom and the number to the left. So that would be 2. And then we can see now that this vertex and this vertex can be labeled, right? Because they have the numbers to the left and to the bottom of them with an actual number. So we have 2 plus 1, which is 3 for this. And we would have 1 plus 2, which is 3 for this. And then we continue. So we do 4. Okay, you cannot see that. We do 4 for this. We do 6 for this. You do 4 for this, right? I'm just doing addition at this point, right? It's not like complicated math. So I continue numbering these vertices. And as you can see, I'm getting closer and closer to point B. So now I would add these last 2 together to get the number for point B. So 35 is what we get. So the number that you get at the ending point is going to be the number of paths to get from the starting point to the ending point. So in this case, 35 is the number. So we have 35 ways to get from A to B. So let me just clear my drawings. So you can see it continues like this, right, until we get 35. So as I said before, the number you get at whatever vertex B is the number of ways to get from A to B. So we are going to try an example. Actually, first, does anyone have any questions? Yeah, it is really easy. So I'm going to put the link in the chat to the Desmos activity, and everybody click on it. So we will be doing, okay, so we will be doing a problem or like 2 problems, right? So make sure you click on that. And let me just like, okay, so this is going to be the first problem you all are doing. So how many direct paths are there from H to I? And I'm just going to show you the student view. So you have 2 problems that you're going to solve. So this and this, write down. Should we get them like 8 minutes?
Sure. We can also just see, once most people are done, we can probably start explaining.
Right, okay.
So right now, for some reason, like the link that you posted, like it shows that the screen is intentionally left blank.
Yeah,
Yeah,
it says there's
so-
nothing on it.
right. So just click
So you-
like next or whatever it says to go to problem 1.
Problem.
Yeah. So right now you should be able to access problem 1 and 2. You won't be able to access 3, 4, 5, 6, 7, or 8 at the moment. And that's because we haven't learned how to do the rest of those things. Yeah. Okay, for the person who forgot how to do this, remember you number the sides, the vertices on the sides that the starting point is on with 1s, right? So I would, in this case, because we're starting at H, I numbered the bottom and the leftmost sides with 1. And then I add the number below each vertex and to the left of each vertex. So I would get the number for the vertices inside the actual rectangle until I get to the endpoint, which in this case would be I. Direct paths, meaning like you don't go backwards and you don't go like left, right? You don't go down and you don't go left. You just go directly. You like travel on the lines. And that's where this method works. If we knew that like, you were trying to take a path that went backwards and leftwards and stuff like that, this method would not work. Yes, there is an actual formula for this. However, we're not teaching that today because you can like search it up and find it, and that's all great. But like for problems where it's like altered grids and where it's like altered grids, right? It's harder for people to like use that method because it's like more complex, even though you could solve it without like issues.
There's no real name. It's just sort of a method. So like you look at the number of like right steps and the number of up steps, and you it's if you want to learn more, I think they're called combinations, and you use a combination when trying to figure out the number of paths.
Yeah. Dash asked, or someone asked, so do you add the numbers on the points? So yeah, what Amy said in the chat. Okay, so I'm pretty sure this dot means that people have actually like done the problem. Make sure you all have like inputted the answer into the actual like thingy, right? Yeah. But okay. I think the first one is like everyone has done the first one. So Angela, do you want to explain?
Okay, so basically this problem is almost the exact same as the other problem, except now there's just more squares. So same thing as the other problem, you're going to label the bottom and leftmost sides with 1. And then same thing as the last problem, you're going to add the left and the bottommost vertices. So that will be 2, and then this one will be 2. I mean, this one will be 3, and then that will also be 2. And then you just keep going, so that'll be 4, and then the top will be 5. And then and then you also have 4, and then 5. And then you have 6. On top of that, you have 10. On top of that, you have 15. Next to the 6, you have also 10. Next to that, you have 15. On top of that, you have 20. And then you'll get 35 on top, and then 35 on the right. So then you add 35 and 35, and you get 70. So I think I see a lot of right answers from you guys. I think you did it right.
Yeah.
I don't understand what you're supposed to put for the answer.
So you're just supposed to put 70. So 70 is the number we get for the vertex, the ending vertex, right? And that
so
will,
you're
yeah.
I thought you're like supposed to like add the numbers under the path or something. Yeah, I was confused.
Yeah.
I mean, I got the numbers on the vertexes, right? But I just didn't know what you're supposed to put as a final answer.
Yeah. Yeah. Okay. So the number you get at the ending point is your answer, right? Yeah. And don't look at the chat if you're already having confusion, unless you're like going to ask a question, because yes, everyone is talking about the other method.
Yeah, right now it's like we're verbally speaking one method and then everyone in the chat is talking about the other method. So if you're a little confused about what's happening in the chat, just know it's different.
Yeah, it's not what we're like learning today.
Okay, well then we'll try to explain this one. So, okay, Shani, could you post the Desmos link?
Yeah.
Okay, so if you're confused about what we're doing in this method, then what we're doing is that we are putting a number next to each vertex in the grid, and that number represents the number of paths to get to that vertex. And so if you go back to like, could we go back to like the previous problem? Yeah, so for a grid like this, what you're doing is that you're putting a number next to each vertex that represents the number of paths to get there. So for example, there's only one way to get to vertex H, because if you want only direct paths, there's only one path to vertex H because you're already there, which is why you put a number 1 next to it. And then if you look at the vertex directly above vertex H, there's only one path to get to it, because the only way to get to it is to move straight up one square. And because we're not moving backwards, this means you can't move left or down. So you can't make a big loop-de-loop and get back to like H or any vertex. You have to just move to the right and upwards. And so because of that, there's only one way to get to all of the vertices that are directly above vertex H and directly to the right of vertex H, which is why we put number 1 next to all of those vertices. And then once we have those numbered, what we do is that we add the numbers that are, we add the number that is to the left and below each new vertex. So for example, the vertex that's diagonally across from H, the number to the left of that is 1, and the number below it is also 1. So the new number for that vertex would be 1 plus 1 equals 2. And then we just continue like that on and on and on. So for example, the vertex, Ishani, could you go to the vertex labeled 3?
This one?
Yeah, for this one right here, that vertex number, in order to calculate it, right now you see it's labeled 3, but in order to calculate that it was supposed to be 3, you added the vertex number that was to the left of it and the vertex number that was below it. So the vertex number that was to the left of it was 1, and the vertex number that was below it was 2. So you add those together and you get 3, and that's the number of the vertex that you're currently trying to find. So for example, Ishani, could you go to the middle one? But don't write the number yet. So this one that Ishani is circling right now, what would be the number of that vertex? Yeah, it would be 6, because you're adding the vertex that was to the left of it, which is 3, and the vertex that was below it, which was also 3. So this vertex would be 6. And so you just continue this these steps on and on and on until you have a number for the vertex that you're trying to find, which is vertex I, because you're trying to find the number of paths from H to I. So you just keep repeating this process and finding all the numbers for all the vertices until you find the number for vertex I, because remember what these numbers represent. They represent the number of paths there are to that vertex. And we're trying to find the number of paths to vertex I. So we want the number for vertex I. So we just continue that until you find that number. I hope that clears it up a little bit.
Mhm.
Okay, so for this problem, it's almost identical to the previous problems. It's just it's a different size grid. And this time, instead of traveling right and up, we are traveling right and down. And because it says direct paths, that means we can only move right and down. So, however, the process is still the same. So this time, since we're moving right and down, we will number all of the leftmost vertices with 1 and all the uppermost vertices with 1, because there's only one way to get to those positions. So all the vertices that Ishani is labeling with the number 1, that's the first step. So now you repeat this process of finding the number for new vertices. So for example, that vertice right there would have a number of 2 because you would add the numbers of the vertex above it and to the left of it, because now you're moving a different direction. So you continue this process and you add the numbers that are above it and to the left of it. And at the very end, you just add the last 2 vertices and you get the answer of 56. So that would be your answer. That's how many paths there are from A to T. So do you guys have any questions? This problem is a little different because you're moving in a different direction, but the process is basically the same.
Okay. Remember, if you have any questions at any time, just feel free to unmute, or if you don't feel comfortable asking in front of everyone, you can private message one of me, Amy, or Angela, yeah, and we'll answer. Okay. So, okay. So we're going to be going over altered grids.
Okay, so this time, basically it's instead of like a normal grid, right? Like it's just a normal, like, I don't know, 4x3 grid. This time there's like a hole in it. One of the like edges, I guess, got like cut out of the grid, and now there's a hole. So how would we find a number of paths now? Because like, would our method still work? And the answer is it would work. You would just do basically the exact same thing, except that you just have to be more careful this time. So yeah, so basically when we're working with a grid like this that's a little bit broken or is a weird shape, once again you start off the same way. Since we're moving right and up, this means that we would number all of the leftmost and bottommost vertices with the number 1. And then we just continue. So we would number the next one, the middle one right there would be 1 plus 1. Oh, 1 plus 1, so that'd be 2. And then if you up here would be 1 plus 2, which is 3. And then up one more would be 1 plus 3, which is 4. And then down there, 2 plus 1 is 3. And then 1 to the right, 3 plus 1 is 4. And 1 to the right, 4 plus 1 is 5. So, and now we have so far it's been the same, but now we have this issue of this hole in the middle. So basically, if there's like a hole or if there's something missing, it's just missing. You can't do anything about it. And normally you would add for that one that Ishani is circling, normally you would add 3 plus 3 for that, because 3 is the vertex that's to the left of it, and 3 is also the one that's below it. But this time there's no path connecting the one below that vertex. So actually you don't add that vertex because there's no path connecting it. So this time the value of this vertex would not be 3 plus 3 equals 6, but it would just be 3. because the only vertex that's actually connected to it is the vertex labeled 3. So that one right there would also just still be 3, if that makes sense. So that's how you would deal with any like empty or missing parts. You just wouldn't be able to add the ones that aren't connected to it. And so from there on, you can just continue to number them. So you have 7 up there because it's 4 plus 3. You have 7 over there because it's 3 plus 4. Then up here you have 14 because it's 7 plus 7. 12 over here because it's 7 plus 5. And finally, you have an answer of 26. And the thing is, I know some people in the chat were talking about like that second method that used like combinations and stuff, but the method with combinations wouldn't work with this one because there's a hole in the middle, which is why this method, it's actually kind of more
Superior.
fun and it's
better.
It's easier. So I would actually prefer this method over the other method. So this is why we're teaching this method.
Also, technically, you could use that like combinations method. However, you would.
You don't want to use it.
Right.
I used to not know about this method, and I would always use the combinations method, and it involved like having to calculate a bunch of different combinations to get around the hole, and that was like a mess. So this method that we're teaching right now, it's like easier and it's more fun and it works for any of these situations.
And it's much easier to remember. So like,
yeah.
Okay. So wait, on the Desmos, is this on the Desmos? I think it is.
No, this is not a Desmos.
Okay.
Angela, you want to do this one?
Okay, so basically this one does not have like a hole missing, but it looks like there's like extra squares tacked onto like a main grid, but don't worry, it's pretty much still the same thing. So you start off by like numbering the leftmost and bottommost squares with 1, and then you keep numbering. So up top, you just keep adding. So for the one that's right there, you get 2, and then you get all those numbers if you just add the leftmost vertice by the bottommost. So then you just keep numbering until you get what you need. But then notice on the rightmost edge that 4 is highlighted in red, and pretty much you, like the other problem with the missing hole, this one right here does not have like a bottom vertice, so you think of that as like a 0 pretty much. So all you have is the leftmost, so you get a 4, and then the bottom is missing, so it'll be like 4 plus 0, and then you have another 4. So then you just so then you just keep going. So then same thing up top, that one looks like it's also tacked onto the edge, that 10. And then you pretty much do the same thing. So the bottom has a 10, but like the left is missing. So then you have like 0 plus 10, and you get another 10. So then you just keep adding, as you can see, and then you just get 30 and 34 to get to point M. And then that will give you 64.
Mm-hmm. So basically, it's the exact same method as earlier. So
are there any questions?
Yeah. Right, missing lines essentially are just 0. And if you had to use like the combinations method for this one, I'm pretty sure you'd have to divide it up into like rectangles, right? To get to like one vertex. And then, yeah, that would not be fun. So this method is superior. Okay, so we're going to be doing a few example problems for this.
That's in Desmos.
Yeah. So so go back to the Desmos. If please don't X out the Desmos screen because we will be using it for practice problems. So yeah, and if you did X out the Desmos screen, I will put the link in the chat. Yeah, it is easy. It takes longer only for the ones where it is like a normal grid. And in those scenarios, it would be fine to use the combinations method because that's like really quick. And if you're running low on time and math counts or AMC, that would be best. But
for like grids where they're missing parts or they're not a normal rectangle, then the path method is actually faster than the combination method.
Yeah.
Wait, so for this, for
Right.
number 4,
Yeah.
wait, I'm not sure how to say it. For slide number 4, on the first column, I guess. Wait. Oh wait, no, I'm on 5. Wait, what? Never mind. Okay.
Okay. If you have any questions, feel free to ask.
Slide
But
number 4 is problem 5. So
yeah.
it may be a little confusing.
Yeah. Okay. For this problem, you would number the top, so it would be like everything. So it's just the sides that the starting point is on. So A is on this side, and A is also on this side. But it's only on those sides. So you'd only number the vertex right below A and the vertices that align with vertex A, like horizontally aligned. So like the ones that are on the arrows are the ones you'd label with a 1. If that clears up whatever you were trying to ask. Okay. Some people I see they're still on that side, like from the previous thing. I'm assuming you are the people who have X'd out or have it open in a different tab. But make sure that you're doing the problems we're currently on. Okay, problem 4 is a bit hard, so we will go over that. It's because it looks weird, problem 4. You probably okay, 4. It has a lot of spaces, right? So make sure you're going from like the bottom and up, or going upwards, and you're on like that you're starting from the left and bottom sides and going like rightwards and upwards when labeling. But yeah, okay. I think everyone is done with problem 3. So Angela.
Okay, so problem 3, you'll notice that the point that you're trying to get to isn't like on the bottom of the grid, but is more like in like the second to last like row. So this one, you're gonna kind of think of it differently, but it's still also kind of the same. So like you'll ignore the bottommost row because you can't like, because for example, if I'm trying to go from point I, I'll go like down and then right, but I'll try to go up to get to point I in a sense, and you're not allowed to go up, if you know what I mean. So the most direct paths only include going straight downwards and to the right. So you'll completely ignore the entire last row. So then same thing, you'll just pretend that that's not there in number 1 on the left and that bottom, in the top. So that if you keep numbering and then you add like the left and the top, you'll just pretty much do the same thing. And as you can see, you have to ignore that. And then same thing for the missing portion, you'll just do the same thing as the other problems. Okay, yeah, so then you'll just get your answer of 18 if you ignore the bottom.
Okay. Does anyone have any questions about that? Okay.
Okay. So
I
oh wait, sorry, you're doing that.
Yeah, sorry. Okay. So we're going from Q to U, right? So that means we want to go rightwards and upwards essentially, right? So first we're going to start by labeling the left side and the bottommost side, right? They're vertices. And remember, I'm labeling these vertices with the 1 because they're on the same side as Q, and Q is the starting point, right? So I go 1 and then 1. So this sums to 2. This sums to 3. And we can continue and do this. So that's 3. And this, see, it has a missing path below it, right? So there's nothing here. So we just label it 3 because there's only something to the left. So we get 3 here. And then 3 plus 1, because 1 is below it, is 4. And then 5. And now you see this point, right? It's just a 3 again, because there's nothing to the bottom of it and there's only a 3 to the left. Okay, and for this point, there's a 3 to the bottom and there's a 3 to the and there's a 1 to the left, so we have 4. And we just continue numbering. So 3 plus 3 is 6. 4 plus 6 is 10. 6 plus 4 is again 10. 20 here, 15 here, and 35 here. So you would get 35 as your answer. How did I get 4? So remember, you have a 1 to the left, right? And you have a 3 at the bottom. So you get
long
4.
left. There's a long path to the left.
Right.
Wait, how did you get that 3 in the corner though?
Like 3 here.
Yeah.
So remember, you have only a 3 to the left, but you don't have something below it, right? There's no connecting line to the bottom of it, right?
Oh,
so
so it's just 3.
Yeah, it would just be 3. So yeah.
Okay.
Yeah, so it's really easy to make mistakes, even if you're using the easy method. This is the easy method. So make sure you're like double checking your work when you do it, no matter what. And if you don't get, okay, you're confused.
Okay, I can try to explain a little bit.
Okay.
Okay, so first I'll explain why we're doing these steps. So I don't know if we specifically told you this, but the numbers are representing the number of ways you can get to that point. So if I write a 1 next to a vertex, it means there's only one path to get to that point. So for example, if I write a 1 here, it's because there's only one way to get to that point. You have to go up. So however, if I write a 2 next to like that diagonal point, yeah, that one. So if I write a 2 here, it's because there are 2 ways to get to that point. You can go right up, or you could go up right. So the reason why we're numbering the vertices is because they're telling us how many paths there are to that point. And the thing is, the reason why we're adding like the vertices, the number of vertices that are to the left and below it, is because the number of ways to get to a new point has to be the sum of all the it has to be the sum of the number of ways you can get to the vertices that are like behind it. So like, for example, from the the point that's labeled 2, in order to get to that, you have to pass through either the vertex that's labeled 1, like in the upper left, or in the left, or you have to pass through the point that's labeled 1 below it. And that means since there's one way to get to the vertex to the left of it, and there's one way to get to the vertex below it, then that means in total there are 2 ways to get to the vertex that's currently labeled 2. And that's why we're adding up the number of the number on each of the vertices, because that's telling us the total number of ways to get to that vertex.
Another way to think about it is if you want to get to a point, you're going to have to go to the, okay, wait, so say this is a grid, right? And if we want to get to like this point, we would have to go from either this point or this point, because we can only travel upwards or rightwards, right? If we want to travel from point A to point B, right? So you would have to add those together, right? Because you can't go this way, right? And you can't go this way, and you can't go this way. You can only go rightwards or upwards. And that's why you add those.
So which way do we add these numbers on those large paths? Okay, so typically when it says direct path from like Q to U, first you try to look at the direction, like which directions are you moving when you go from Q to U. So when you're going from Q to U, you're moving like right and up. So you're moving to you have to move to the right and up, because it says direct path. So in this case, it'd be right and up. And so which way do we add these numbers on large paths? So if you're moving right and up, you first number all the vertices that are leftmost and bottommost with 1. And then you look at, I think one way to think of it is that you look at which vertices flow into a new vertex, because if you can only move right and up, then that means the vertex that will flow into another one will have to be the vertex that's to the left of it and below it. So for example, the vertex that's numbered 2, the vertices that would flow into it would be the one that's labeled 1 to the left of it and the one below it. So whichever ones that are flowing into another vertex, then you add the numbers on those. And the thing with holes is that you just have to be careful, because like, for example, that hole up there that Ishani, or the vertex up there that Ishani circled, this one might confuse some people because they only see the path that was coming up from below it, but there's actually also a path coming from the left that flows into this vertex. And so you would have to add the numbers on both of those to get the new one.
Yeah.
Does that answer your question to some extent? And if you get more confused later, you can always just ask, because this can be a little confusing sometimes.
Yeah. Oh. It's kind of hard to explain.
Yeah.
Okay.
That's okay. Just watch a couple of examples and maybe it will suddenly click in your head.
Yeah. Okay, let me see. Did everyone? Okay, I think some people are still working on problem 5. So like 2 more minutes. Yeah, the recording would also help. And we do post the slides. So like you can look at that after class if you still are confused. Yeah.
Okay, so I think most people are done. So I'll start going over this question. Hopefully it will clear up a little bit of the confusion. Wait, Shani, do you think you could like zoom in a little bit? Because it's a little bit small.
Wait, I think I am able to somehow click on this, but I do not know how.
I think,
Well, that
there.
also works.
Yay.
Okay, wait, I have to clear the drawing stuff because, yeah. Okay, yeah, you can explain now.
Okay, so for this problem, we are moving from point A to point B. So we're gonna start by, once again, since we're moving right and down, that means we will need to number all the vertices that are leftmost and upmost with the number 1, because there's only, those are the vertices that A directly flows into. And so there's only one way to get to each of those, which is to either move completely right to the right or move completely down. And so that's why we're labeling all of them with 1. So the next one we would number would be that one right there. So we would number that with a 2 because the left vertex, that's the left vertex that's labeled 1, and the top vertex that's labeled 1 would flow into that. And then we would continue down this row because this row has enough information for us to fill in. So 2 plus 1 would be 3. So that vertex would be labeled 3. And then 3 plus 1 would be 4. And then 4 plus 1 would be 5. And then 5 plus 1 would be 6. So we've labeled this entire row. And then we have this vertex over here that doesn't have a vertex above it. And because missing paths are basically like 0, there's nothing there, you just put on 6 there because there is a vertex numbered 6 that flows into it. And then we can go down to the third row. So down here, the first one, the leftmost one in this row would be labeled 2 because there's only one vertex that flows into it, and it's labeled 2. And then to the right of that, the next one would be labeled 5 because there's a vertex of 2 and 3 that both flow into it. And then the next one would just be labeled 5 because there's no path connecting this vertex from above. So it would be labeled it would just be labeled 5 again. And the next one does have 2 paths flowing into it. Both of them are labeled 5. So this one would be labeled 10. The next one would be 10 plus 6. So that would be 16. The one after that would be 16 plus 6. So it would be 22. And then the one to the right of that would also be 22 because that one has no vertex flowing in from above. So it would just still remain 22. Okay, and now we're on to the last row. So the one over here, the leftmost one on the bottom row is still labeled 2 again. And the next one would be labeled 7 because 2 plus 5 is 7. The next one after that would be labeled 12 because 7 plus 5 is 12. Why 10 plus 6? 10 plus 6. Okay, so for this one, there's a vertex labeled 10 that's to the left of the one in question. And there's a vertex labeled 6 that's above the one in question. And because we're moving left and right, that means you can get to that vertex by going down from the one above it or to the right of the one to the left of it. And so because of that, we add the numbers of both of those vertices together to get 16. So that's why we're doing 10 plus 6. Okay, I hope that cleared it up a little bit. So the next one would be 22 plus 16. 22 because it flows in from the left, and 16 because it flows down from above. And that is 38. And the next one after that, 38 plus 22 would be 50 or 60. Sorry, I can't do basic math. Okay, and finally we would add together these and it would be 82.
Oh yeah, rip. I can't read my own handwriting apparently. Yeah, so 82.
Yes.
Let's hope I put the answer in correctly into the decimals. Yeah, I did. Okay. So yeah, the answer is 82. If anyone has any questions, ask them in the chat. And if not, I will clear all my drawings and we can continue. Okay. Yeah. Okay, so we're doing 3D paths and more.
Okay, so I know some of you probably have just started to understand 2D paths, and now you see we're going to do 3D paths, and you're just going to be like, oh no. But actually, 3D paths are exactly the same. They're really no different. It's just that now, instead of having two vertices flow into one, sometimes you have 3 vertices flowing into one. And we will walk it through. We're not going to do some really hard problems with this. So yeah. Okay. So for this one, we would need to calculate the number of paths from A to B. So first of all, we're calculating the number of direct paths. So it's okay. If you feel like you just understood the 2D path thing, it's okay if you don't fully understand the 3D path thing. But once you do understand the 2D path thing, the 3D paths will be a little bit easier. So the first step is the saying you number all of the vertices directly connected to A with a 1. So this would mean that if you wanted to flow up, since you can flow up from A, right from A, and forward from A, then you would number all 3 of these with 1. And then the next step is that you do the thing where you add together the vertices that are flowing together. So for example, that the 2, oh, well, I don't know how to point, but yes, that one. That one is connected to the 2 vertices labeled 1. So you would add together those, the ones that are connected to it to get 2 for this one. And then you do the same with the other ones, because yeah. So you label each of those with 2. And now you can probably guess the last step. So the final step would be, since the only one we have left is point B, we would sum all the vertices that flow into point B. So in this case, it would be all of the vertices labeled 2. So 2 plus 2 plus 2 would be 6. So B would have a value of 6, which means that there are 6 paths from A to B.
Mm-hmm. So in math counts, I think they've asked like a few of these questions, specifically like 3D paths, where it's like an ant is crawling on the outside of a cube. How many ways can it get from like point A to point B? Yeah, we won't try 40. Yeah, but yeah, so this is helpful when you have 3D paths. So let us try one on your own now.
It's okay if you don't get this one. Okay, when I looked at this, I was like, okay, and then I tried to do it and I got it wrong. So so it's okay if you get this wrong.
Right. So for this question, I shall it's on the Desmos. Okay, my computer is
I can unhide it.
Okay, yeah, that would be really great.
Okay, if you want to take a look at it on the Desmos, you can. It's like 2 slides forward from the last one.
Yeah. Also, we have a harder problem if after this class you decide you want to challenge yourself more.
I feel like if they do like that hard problem right, we should give them at least a point.
All right. We'll give you like, I don't know.
1 point. 1 point.
We should give them more. It's
no, I don't think we should, because then there's gonna be like one person who looks it up or something.
Oh, yeah. I mean,
or uses a different formula.
Yeah, true.
But
we can ask them to explain it.
Yeah.
And then we give you like 5 points for it if they explain. You know.
If you explain it better than we can.
Yeah. I made the problem, the harder problem, and I struggled with it. So yeah.
Yeah, this is the hopefully easier problem.
Yeah. Also, okay, yeah, this is a prism. For a moment, I thought it was a pyramid because I'm smart like that. Yeah. Okay. Okay. So the problem is an ant crawls along the outer edges of a 2 inch by 2 inch by 1 inch prism to get from point A to point B. Assuming it walks exactly 6 inches and only walks along the lines shown, how many pats can it take? Now, one important thing to note is that there is no line here. Okay, this line does not exist. Okay. So like remember that. And it purposefully does not exist because the ant is crawling along the outer edges of a 2 by 2 by 1 inch prism. So, yeah.
Shani was generous enough to provide us with a diagram for this one.
Right. The hard problem does not have a diagram.
Which might be why it's kind of hard.
Right, just maybe. Yeah.
It's okay. Don't worry about the hard problem. Just focus on this problem for now.
Yeah. A lot of people are actually getting it. Apparently.
Oh,
So that's good.
maybe we should attempt the hard problem.
Yeah. Okay. Okay, yeah, that's fine if you're rejoining on a computer. Also, if you're doing this on a computer, right? Like if you're not doing the math on a pen, not a pen, on a paper, it might be a bit harder because like, yeah. Yeah, in math counts, make sure you like use the diagrams you're given. Yeah. But in this case, it would probably be easier to do it on a paper. Yeah.
When we say easy problem, we mean like the easier of the two problems. Both of these problems are hard.
Right.
Just getting that out of the way. If you are struggling with this problem, that is okay because I got it wrong the first time.
Yeah. I made it and then I got it wrong. And the only reason I knew I got it wrong was because I went back and did it again. And I was like, why did I get two answers? So yeah, that's always great. At least I didn't give you all the wrong answer and then tell you it was right or something, you know?
That would be very sad.
Right. Yeah. So let's see how many people have gotten it. Okay, actually a lot of people are getting it. So like good job to you. And for the people who aren't like really understanding it, you can ask us questions if you have any. But remember, you want there are 3 steps. You label the sides, the vertices that you can get from directly from A, like with one straight line, like with a straight line, as 1, and then you add together the vertices that have all points that are to the back or to the left of it labeled. You add together those numbers to get the number of the point. And then you repeat that. I'm pretty sure the answer should be in the, what's it called? In the Desmos. It should say like correct or incorrect. I spend more time on this than I'd like to than I would have liked to, just to make it show correct or incorrect. So yeah, that's kind of sad. But yeah, I can see what the answer is. I was gonna pull it up on my phone and then I realized I have a computer. The answer,
it says 30.
Yeah, it should be 30. I did it and I got 30. Presumably I did it right.
Okay, shall we explain now?
Yeah. Okay. So remember everyone, you have to, okay, yeah. Okay. So remember, we want to number the vertices that are directly connected to A, like that align with A, like that are on the same side, are on the same edges that A is on, right? So we would label this one, this one, this one, this one, and this one, right? It was 30, right? So now we would add this, and we would get 2, right? So 2 would be this vertex. Okay, I'm gonna use a different color. And then now we add this, and we get 3, right? Right, so 3, then we continue. So we do this and this to get 2. Let me just like, yeah. Okay. Amy, can you post the link again? Yeah. And then the 1 and the 2 add together to this point to be 3. And then 2 and the 1 add together to be 3 here. And then the 3 and the 3 add together to be 6. The 1 and the 1 add together here to be 2. The 1 and the 2 add together here to be 3. This adds to be 6. And then, wait, hold on, I did wrong.
Oh, wait, that's not 6.
Oh, wait, no. Wait. Oh, yeah, rip. Okay. Yeah, this point here is 4, right? And then this point here is 7. This point here
Wait, that's
is,
not 7.
yeah, I can't add. Okay. This point here is 10, right? Yeah. 4 plus 3 plus 3 is 10. Then 3 plus 4 plus 3 is also 10, right? And did I do this wrong? I did it.
Well, let's see,
Okay.
guys. Where did Ashani make her mistake?
Okay, an easier, okay, so I find an easier way to do this is to divide it into planes, right? So this would be the place that A is on, and this would be the place that B is on, right? So B would be here, right? So like this would be the back, and this would be the, okay, yeah, but you know, this is the back, so this must be the front, right? So we know that this is 1, this is 1, this is 1, this is 1, and this is 1, right? Okay, wait, let me just erase all this stuff.
No.
No, I'll
I
just,
was trying to find your mistake, Ashani.
oh, wait, let me just show them like the grid way.
Okay.
Oh wait, hold on. Yeah, this. Right. So this is so we start with the back. So we know that we need to have the 4 other sides don't matter because we're dividing this into planes, right? So this would be 2, right? Because we have the 1 and the 1 here. So this would also be 2, right? And then 2 plus 1 would be 3, right? Because remember, we're adding the numbers that are like behind it, that are to the left of it and that are below it. But because this is the back, there's nothing behind it. So we would have 3 here, right? Then we would have 3 here because there's nothing behind it, and 1 is below it and 2 is to the left of it. And then we'd add to get 6 here because nothing's behind it. We're adding 3 below it, and we're adding 3 to the left of it, right? So this is 6, this is 3, and that's 1, right? So now we know, so say we want to find this point, right? We have to do 1 plus, okay, so we have to do 1 plus this one, because those are the only ones that connect to it, and we get 2. And then we have 2, and then we have this 2, and we have this 1, and they add to make 3, right? And then, okay, well, let me just explain this and then like using the grid method, right? Because, or not grid method, the plane method, right? Okay, well, maybe I'm making it more confusing. Okay, so this is 2, right? So that corresponds with this point, and the 3 corresponds with this point. Okay, right, and then this point down here is a 2, right? Because the 1 plus the 1 is a 2, right? And then this here is a 4 plus nothing behind it, so it's just a 4, right? This is a 4 plus a 3 plus a 3, which is a 10, right? This is a 3 here. This is a 10 here. And this is 26. Okay, wait, I'm pretty sure I did it right. I was right the first time. Okay, wait, hold on. Okay, so the 2 and the 2 add together, right? We don't add this 2 because it's not connected to this point. So we get a 4, right? The 4 and the 3 add together, right? So this 3, and this 4, because that 3 is right behind this point, right? So we get a 10. We get a 2 plus a 1, right, to get this. And then we get a 3 plus a 4 plus a 3 to get 10 here, right, which is exactly what I have in the grid. And then the 10 plus the 10 plus the 6 is a 26.
Did anybody else get 26? If you just get the no. Wait, what did you guys get?
Well, we have a variety of answers. So that's always fun.
Do you guys know where Ishani went wrong? Because I don't know.
I'm
I
pretty
bet people are lying about getting it correct because they already know what the correct answer is.
Okay, I think maybe what I did when I got 30 was I assumed there was a line here, right?
I feel like that might have been what you did.
Right, maybe. Okay, and then as a result, I got a 6 here, and because of that, I got a what's it called? 6 plus 3 plus 3 is 12, right? So I got a 12 here, and then
Yeah, I think that would give you 30, I think.
Yeah.
Something like that.
And then
because
I got
it would
a
go
12.
both ways. Yeah.
Right.
Okay. Well, we know Ishani did the problem.
Okay, well, when I got the answer, then I got the problem wrong, but this time I got it right. The answer is actually 26. Yes. So everyone who got 30,
you guys all made the same mistake as Ishani.
Yeah.
Ha! Joke's on you. I got 54.
Well, yeah.
Wait, 54 divided by 2 is 27. That's close to 26.
Right. Yeah.
Okay. Okay, but okay. It's okay if you don't know how to do this problem, just like saying that outright. It's okay if you don't know how to do this problem because as you can see, Ishani was struggling a little bit with it. So if you understand the gist of it, that's fine because this problem is pretty hard. And right. Yeah, I think pretty hard is an understatement.
Right, and we have a harder problem just for,
Yes, we're not going to do the harder problem.
Right.
If you have a lot of time, you can attempt. But like we're not giving you. Yeah.
Yeah.
Okay, we're not doing the harder problem in class though because
that
would be a kind of torture.
Yeah. Okay. Just quickly, can we go over that one other path? I promise it's not 3D. It's like not 1D.
1D.
Yeah. But yeah. Am I supposed to go over this? Or
I think it's Angela.
Okay, yeah. So this one is kind of like it's like 2D, but like it's not a grid. It's more of like a triangle, I guess you would call it. But pretty much it's the same. So you can see that the only ways to get to the A is from the left and the right. So each of those will be 1. And then same thing on the edges, you'll still have 1 to get to the A to the T, and then 1 to get to from the T to the H. But then in the center, you have like, oh yeah, you'll just like add 1 plus 1 to get to 2, basically, because you have to go like inwards. And then same thing for the H's, you'll add the T's to get to the H's. So then you have like 2 plus 1, which will give you 3. And the same thing for the other H. And then basically you just add all of those up. So you will get 1 plus 3 plus 3 plus 1, which should give you 8.
Yeah. So basically, this is kind of a completely different problem, and it's counting paths. And the question was beginning with the letter M at the top of the triangle and reading diagonally downward to an adjoining letter, how many ways is it possible to read math? So remember, the only constraints we had here was that it could go down. So yeah, it's 8. Does anyone have any questions? Because that was kind of like a 360, you know, like a bit of a curveball. And if not, we can move on to the Kahoot,
Yes.
right? And there
That
are
sounds
no,
like a good idea.
yeah, there are no 3D problems in this, because I was really nice. And yeah, right, it's 40 problems, you know. All of these are in 4D. So
Classic.
yeah.
Let's
can I-
do cheat mode.
I feel like that would be a bit hard to do. So the code is 990-0598. I think I joined one of the previous Kahoots, but this time I won't, because this is actually a hard topic, and like, you know, I want you all to, you know,
Not be
Do-
discouraged more than
Yeah.
you already are.
Yeah.
Okay, but okay, but in all seriousness, I do hope you understood the 2D paths thing, because I think you guys understood that. It's just after we got to 3D paths, we got a little bit
yeah. Yeah. 3D, yeah. 3D is very easy to mess up on because you have to think in 3 dimensions, and that's always great, you know?
Oh wait, Ishani, could you set the settings? Go
See,
to
the issue is you have to think, and that's
Oh.
where
it's the
I
yeah,
kind of
that
have
dot.
trouble with.
Right, thinking is very hard.
Yeah. And then it's the very top. Show yeah. Yeah.
Wait, hold up. Is this
It-
it?
Yes.
It
It's
takes
already
too much
green.
thinking to think.
Okay. I don't-
Everything else is fine.
Okay.
Oh, I don't think you need to turn on autoplay, because then we might not. It's
right.
okay. The rest of it's fine.
Okay. Okay. So I am assuming, okay, wait, there are 25 people in this class, in this Zoom right now. Okay, why are there less people now? Like, what happened to you?
Maybe
but
they're trying to join as an alternate name.
There's like 5 real people in this place.
Yeah. There should be like at least 20 of you, but it's already 11:16, so I'm just gonna start, and you all can join when you know, when your computer starts working or when your stuff starts working. Okay, I'm really hoping that I did put in a diagram.
I think you did.
Okay, okay.
Well, what a great diagram.
Yeah, I know. It's very complex. Very complex. This is probably the most difficult problem of all of them.
Yeah, even harder than the hardest problem that we were talking about.
Yeah. Okay, yeah. So for yeah, it's 3. Remember, let me just quickly draw if it's gonna let me. Okay, yeah. So remember, we'd label it 1, 1, 1, and then we'd add the 1 and 1 together to get 2, and then we'd get 3 for B. So like, yeah. Good job, Aryan and Advika and Anik for being at the top. Okay, next problem. How many distinct ways can a late be bug? Okay, it's the same problem, but a different diagram. How many people are in the Kahoot? I don't know if I'm able to see that somehow, but
I feel like there's just some people not on the Kahoot.
yeah. Okay.
Some people probably just have their camera off and are sleeping.
Yeah. It would be kind of hard to join the Kahoot if you're sleeping though. So like, I don't know.
I bet like some people play Fortnite, but they joined the math class just so they could play Fortnite.
Some people might have created another one just to make people suffer and wait
Right.
while their
That-
main one can get points.
Yeah. Okay. So for this problem, wait, show media. Okay. Remember we had 2 here, 3 here, and then 1 for these, right? From earlier, right? So this 2 would go across here, and then we get 2 plus 3, which is 5 at point B. So yes, it was 5. Some of you clicked 6, and some of you clicked 4. I'm assuming you all are guessing or misclicking. Please
Whoever
try.
clicked 4 just know.
Yeah. But yeah, I actually tried to do the problem. Cause yeah. Okay. So same problem, different diagram. Okay, last time we only got 16 answers. So yeah. Okay, so the answer was 6. Again, remember 1, 1, 1, 1. Then this is 2. This is 3. This is also 3. And would you look at that? 3 plus 3 is 6. So that is our answer. Okay, so this is actually harder. So yeah. Do you have?
Some people have already answered.
Right. I feel like these are the people who are getting it wrong. Just like, I don't feel like you could do it that quickly.
How many people are giving up? Don't give up.
Yeah.
If there's so many people giving up, if you actually do the problem, you might actually get a lot of points now.
Right, exactly. Inspirational speeches. Yeah. Try because no one else is. But yeah.
Either that or there's one person that's actually doing it really fast.
Right. One person just is like a computer.
Yeah.
Yeah. Okay, I'm gonna wait for 16 answers because that's how many we got last time.
I'm starting to get confused, and this is not very good.
Yeah. I mean, you can always guess.
How do you even do this that fast without even looking at it for a long time?
I think they just guessed.
Right.
Like, how do you calculate all those paths?
Yeah.
All right, 16 now. I did the only even number, which is
Mhm.
red.
Yeah. I was about to say none of them are even.
I don't
and
think
then-
it's red, bro. I don't think it's red.
Okay, yeah, there's actually a lot of people who got it right.
right. Which is good, but like,
But I feel like half of them were guesses.
right.
I think a
okay,
lot of people actually guessed. Oh,
okay.
and we could calculate it. Yeah.
I made such a good educated guess.
Yeah. I mean, at least, you know, you got it if you got it. Well, okay. So basically, as you can see, I am numbering
I
the
messed
vertices.
up on the threes. I messed up on the threes.
Yeah, it's really easy to mess up when you have a complex grid. So that's always fun. We went 43, and then 43 plus 12 is 55. Okay. So yeah, you'd get 55, as you can tell by my beautiful diagram. So yeah, just see where you messed up, and then I will clear. Okay. Good job, Advika.
Vika's still in the lead.
Yeah.
What? Hold on.
This ladybug is like having an adventure here.
Yeah.
Educated guess, my guys.
This ladybug is like traveling the world at this
Two,
point. Maybe.
Nice
Um,
job,
Zero.
Arian. Nice
three,
job, Arian.
two,
Your dog looks
It's
exactly
literally
like
zero.
mhm.
You
five.
can't do it. It's zero. So there's no correct answer. Since you're only supposed to write
Oh,
down
yeah.
I'm just
things.
gonna start guessing at this point. I don't want to do math. This is too hard.
Did the 3D problem hurt your brain too much?
It's so hard problems.
Okay, if you think about it, there are 3 problems
hard.
left. This is the 3rd last. You know, you can do it.
It's too hard because
Honestly,
there
there's
is no
probably like a
correct.
pattern here that someone could find out and like solve in like 2 seconds. Am I missing something? I feel like I am.
you are missing something.
Okay. 5 seconds. You all can do it. Well, you can, yeah, rejoin. Right. This ladybug is going places, you know? Okay. Okay, it was 132. So yeah. Wait. Okay, this is beautiful.
Okay.
Hopefully you can see the grid. If you can't, I don't blame you. So 3, 4, 5, 6, then 2, then 5, then 9, then 14, then 20, and then 5, and then 14, and then 28 and 48, and then it's 14 here. 42, I believe, right? Then 90, then we get 42, and then finally we have to add 90, and 42 together, and we get 132. I think first place has been getting 5 points for the past, like, I don't know how long. But yeah, good job, Advika, for continuing to be first place. Okay. If I want to walk home from school every day, okay, I think
If
the
you're
English
route,
and- yeah,
look, this one's easier. You
yeah.
guys should at least calculate this one.
right,
I know you can.
right. Yeah, this is much easier. We only have one problem left after this, so yay. It means a direct route because, for example, if you're going like up and then you go right and then you go down, it won't be 7 blocks. So yeah, I'll give you a hint at 30 seconds left. If anyone is still struggling.
Wait, Shani, is the last
This
one
was
hard?
the worst.
I don't
This
think
was
so.
like the worst class out of all of the classes for some reason for me.
Oof,
I hated this class.
oof.
Yeah, the content's
I-
a little different.
The
Come on,
hint
guys.
is that the answer is red.
Hey, everyone, put the
Shani.
answer. Put the answers.
No, that's not nice. Shani, you just penalize everyone who actually tried to answer.
Right, but like, you know, it's only one problem. You know?
Yeah, one problem is probably the, oh my gosh. You
Literally
penalize that one
everyone
person.
Educated guess goes.
I'm in
Yeah.
ninth.
Yeah. 900.
Whoever educated guesses is so stupid.
Okay, yeah. So for everyone who got red because I told them it was the answer, yeah. I'm just gonna like label
No
this.
words.
I feel really bad for the person who put 50. Yeah, sorry. To that person.
I put 50 wanted to speed through this quiz.
Yeah. I mean, it didn't help.
I already left the Kahoot. I failed.
Oof. I mean, there's only one problem left. Okay, so it was 30.
Oh, it's Shani, it is 11:30, so
I mean, there's only one problem, so
is it easy?
I don't know.
Oh, okay, it's hard.
Okay.
Let's skip it. Oh,
Well.
the diagram didn't match. Okay.
Yeah.
No, there was not a last question.
Yeah.
Oh, Audrey got everything right. Good job.
Yay. The top 3 got everything right.
Who is
apparently.
Poyo?
Dina.
Okay, if you are Poyo, you should put your name in the chat.
Should we give like top 5 people
Yeah.
points?
Also,
Okay.
if
Poyo is
you're-
Christina. It's a Roblox username.
Wait, who? Christina.
Poyo is
okay,
Christina.
Christina.
Okay. And
And
who's
then-
4D?
Yeah.
Sure, you're wrong. Okay.
Okay. Good job, everyone.
Okay. If this class was a little rough for you, that's okay, because this is a hard topic. And we
Right.
probably should not have done this 3D.
Yeah, probably. But you know, that's fine. Okay. Okay, yeah.